So, not always, but I mean, if you had a justified reason, and I trust that you'll actually get your stuff done, that's fine. So, robot people, if you talk to me prior to class, this is not probably going to be one of those last minute, like, oh wait, let me go do this. Robot people, we're not sure what our homework's going to be yet, but right now we're saying it'll be 2 through 7, and then we'll go from there.
So what's today's lesson?
Because there are robot people not in class. They are skipping class to work on their robot, and
I hope that's part of today's lesson. Is Matt and or Patrick part of that?
what?
Matt and Patrick?
Whoever came and asked me, and those are Math 7 people. So,
I know.
This is what we're working on today, right?
rigid transformations.
This is the fourth.
That's all.
Wait, what's this?
Each of your teams needs one Chromebook. I mean, at least. You can each have a Chromebook if you want, but each of your teams needs one Chromebook.
You can't wear my
Yeah, Mia. You have no friends.
Hey, Oliver, am I your friend?
So you want to go CC3,
You're my friend.
611.
No, Alex.
I paused the recording, my bad. Set up a page just like this, challenge, moves, details. That's all you really need.
I need a ruler.
Then, people on the computers, you are going in 611 to the key lock puzzle. Right here. Your task,
I'll just ask.
your mission, if you so choose to accept it, this message will self-destruct, is, I've never seen movies like that. It's like, yeah, your mission, if you choose to accept it, blah, blah, and then it self-destructs. You go here to the key lock puzzle. It is going to tell you where you start. You are going to set up a series of transformations to move the key into the lock. So essentially I just kind of want you guys to play. But if I click this, this is directional move. And what do I want it to do? Here, give me your eyes up here for just a minute. If I do this, and I hit play, I haven't used this yet. Yeah, maybe that makes sense.
It's challenge, moves, and detail.
I might have broke it. I had this working on my computer. On my laptop at home, this worked easier. Oh, yeah, you gotta hit the check. Sorry. I hate when they grade things out. So, that check right there, you have to hit that once you tell it what to do. So, if I click this, this is straight line moving. If I just tell it to move x minus 3, that just moves my x left 3. If I click on the rotational, and I click left, counterclockwise, left 90 degrees, and tell that to do it, it then turns it left 90 degrees.
Make it spin around, but
No, you want to, in as few moves as possible, get the key in the lock. Because then you have to write down what the moves were. Somebody in the back needs to be logging into a computer. Don't make me take away your fruit roll.
I'll take it.
Considering that Ian's sitting there just consuming a fruit roll-up, I don't know why you're upset at moving it.
No, because I told you you're logging like, okay, and then you just have to remind us a minute later.
So I don't want to give away too much, but this then is a reflection of either of these. It will reflect. So then this is asking you what you're reflecting on. See? So I set up a line, x equals 1, and I just reflected on that.
It turns the thing.
I don't know how to do this.
Thank you.
So we are going to use Discovery Learning to figure out how to do these. So once you think you have puzzle 1 solved, raise your hand. Give me over your gloves. Okay, well then move on, but we'll go over puzzle 1 in just a minute.
Can I go on?
Yeah, go on. Now, hold on. You have to write out the. So, hold on. I guess my directions are not clear. One person. So, if this got me in the key, like in the hole, I would write. I'm not correct at all right now.
Oh, right.
I would write that my transformation was x minus 6, y minus 4. And you need to write your start, too, by the way. So we'd say start 4, 2. Then I transformed x minus 6, y minus 4. That didn't get me there. So I can either add another transformation or go try again. So I think I need to go one more left, a couple more down, and my key's the wrong direction. So I guess we can do the first one together. So if I modify this then, hey, you can double click to modify. So I had already checked it, but if I double click it, I can modify. If I go left one more, down to, ooh, that works, but I'm not right yet, so I'm going to keep that. And then I want to rotate, right?
Yeah, that way you can check it.
No. Oh.
Oh, baby, it does work.
Wait, well, I
So
got it.
what I would write
You got the exact thing.
is start 4, 2.
Oh, in details or in words?
So then I'm going to say
What?
x minus 7. Oh, so puzzle 1.
Yeah.
These are your moves.
Oh.
So puzzle, I would honestly, you could put this in your puzzle 1 set, or depending on how big you make your columns. You just need this somewhere. Eventually, it's really going to matter that you know where your point starts. Right now, for the puzzles, it doesn't really matter, but I want you to have it written down. CPM doesn't care that you have it wherever you want. Like if you want to put it in moves.
Hey, look, you put it in
To move, you have to start somewhere. You're stressing me out today. To move, you have to start somewhere. So put it in moves if you want. I don't care. Then this in details, what we did was, anyone know the name when you slide, the technical name for a slide on a graph? So rotation turns on the graph. So we did do a rotation, but in my details, the first thing I did, so if I set this up like your columns, these things would be in my middle column, right? The whole, like what you did. Then in details, this, when we slide, is called a translation. When you translate something, you slide. Then we had a rotation also. K-T-I-O-N. So we did a translation and rotation. This was puzzle 1.
Yeah.
That's ask me what challenge was it, what puzzle was it? Was it? Now that's not the only option. I could rotate and then I could slide. I could slide once, then rotate, then slide again. But you want to try to find the most efficient way.
I flipped it to translation.
So a flip is a reflection. Okay, so we didn't use it, but this is reflection. Okay, so if you need to talk about that, that is a reflection. And now just play. As you get done with puzzles, write them down there.
What? You have to move it
once you get it, write it down so that then when we come back to it as a class, you can tell us what you did.
What? Okay, I'm not sure I understand how this reflection works.
Oh no. Oh, wow. It's this. Oh no. It's this. I just did two. Then you can move it over and down. Okay. Over one. No, wait. Oh, what? Oh yeah, you want to go down. No, you move down. No. 1, 2, 3, 4. Yeah!
So again, CPM and I have some disagreements where they, in your book, have like slide, turn, flip. The technical names of that is translate, rotate, reflect. Right, translate, rotate, reflect. Anyone on puzzle 4 yet?
I just finished puzzle.
Oh, you're like in 4?
It says in
No, I'm actually past it.
for the fourth one.
Yeah, she's
Mhm.
Wait, how do you write out?
So you reflect over a line. So if I have to reflect,
Is that just called
so say I'm going to reflect my key across. Where's my pen?
No, I know how to do it there. How do I write it down?
I know.
This is the triangle.
We write R X equals whatever your line is.
Oh. Okay.
Or if we rotate, we can write rotate, like R-O-T, and then you have to say how many degrees and what direction, which they use clockwise or counterclockwise. And actually we have positive and negative. Positive, hey, this is the weirdest part of this. Give me your eyes for just a second. A positive rotation, I don't have everyone's eyes, goes this way. It's the weirdest. In my opinion, this is the dumbest thing about math. Because all clocks go the other way. But a positive rotation in mathematics, if you told somebody, rotate this key 90 degrees, it would go this way.
that is.
But if you said rotate the key 90 degrees clockwise, then they know what direction to go. So if you aren't told direction, positive is counterclockwise. I know. I'm sorry, I didn't make that choice.
This is not our fault. Can I move on?
Can anyone tell me what they did for 2?
Yeah.
Or you want to come up and do it? No,
Wait, can I?
you do it. Yeah, do it all.
Do it one more. Yeah.
If you want to move your key really far, you can reflect over a line far away from it.
Do it the other one. Do it like 1 positive. 2.
How? So, there's a lot of ways to do this, but Naya reflected over the line x equals 1, and then translated 1 right, 4 down, and unlocked puzzle 2. Go ahead and click next puzzle, and then we'll wait for people to.
Wait, now we have a little pink away. No, we need to make a blue dot. Oh, wait. I think I know.
So translation, you never have to write out translation. You can just say T, X, whatever, Y, whatever. So guys, for translation, that's how you would write it. Reflection, and normally, actually, once you get into technical writing, you'll say like reflect X equals something. And then rotation, you just put the ROT.
Which is we have to move this up.
No, so whatever. This is a bit excessive. That's also why I need to print the papers. Yeah. Who's easy? Who's Ray?
Oh, now I understand what the CCW is.
Counterclockwise.
Yeah.
Wait, so now that we do this, we'll just move it back up, because now it's in the third grade. That'll just be a lot more steps. Now go up on 6. Or you could.
So wait, how does X equal 4? How does that work?
It tells you where the line is. So that I wanted to do one that I would write the whole thing out for you guys in technical, like how we would write it
Oh, I see. It basically just flips it to
across that dotted line. Because that line shows all that, like all points where X is 4. So this I would have rotate, and I went counterclockwise, so it is just 90 degrees. But you can put CCW if you want. Translate.
Negative 3 when it gets to 7. That's 7x. I mean, yeah, 7x. And the height to 5.
That's all I would need to write for that, guys. I rotated 90 degrees. I translated 7 and 5. And I reflected. That's the short.
No, that's 3.
But that's not the only way. There are a bajillion ways to do this.
I'm doing that.
You can make it go all over the place.
So there's a new commercial for one of the Subaru dealerships, and they're talking about the inventory that they have and how they have like all of this and all of that. And he's like, I'm not very good at math. But that means your probability of finding the vehicle you want here is like a bajillion %. And I really that probability is most often talked about in fractions and decimals, and once you bring in percentages, you're no longer talking probability, you're talking just like chance, like a percent chance. Which, they're the same thing, but when we talk about probability, it's this out of that. It's fractions. Fractions are what we use for probability. Piper's cracking up. She's like, God, he's a nerd.
I do the same thing with stuff though. I go super like, that's wrong. Physics says that's wrong.
And bajillion %? Really? Come on.
It makes people like them. So it makes people think, oh, they're right.
I remember their commercial, right?
I
How annoying it is.
Anyone have 4 done and you want to come show us what you did? Alex, you want to come on up? Have it do this again and move on to my next puzzle. Yeah, and all geometric transformations have, you know, like slide whistle noises that go along with them, so you gotta go all that while you're doing it. Don't do that during the state test, probably.
Oh, whoops. Wait, there's a red line where I was supposed to hit with I know I do that all the time. Oh, wait.
So you did it in only 2 moves,
That's what I was
Alex.
trying
So
to
you
do.
did a rotation, an A
Yeah,
translation.
same. We did the exact same.
1 rotation, 1 translation. You're locked out. I don't know what that is. I don't know what you did.
I broke it.
If I say 7 minus 5 is 2, and you say 7 minus 5 is 2, you can now just count.
So you have to get around that. Are you understanding it? So you cannot travel through this, and you cannot move this. You must travel around it.
Oh no.
Oh, this is cool.
Now I wonder if I can reflect and hop across it.
I think you might be able to.
So if I try, now if you change what reflection you click on, I can reflect on a Y line. So what if I reflect on like Y equals 2?
Oh my god.
Ah! Blocked. Well, let me do it.
It's like a really high wall too.
If you rotate and then
right?
you build like what if you so you're like this and then reflect it over and
I
over.
ripped off my tag.
I could, but I'm gonna have a ton of moves. You're describing like a 6 move.
Yeah. What did we get you?
Oh no.
Wait, that goes.
Okay, now I need to wait, no.
I did
No,
puzzle
let's
five.
restart. Can you do it?
Oh, I did it!
Move it, and then let's go. Yeah, no, that's
I
one.
did it in both steps.
Yeah?
Dos? I think I can do it in Dos.
How can you do
Yeah,
it?
I did it too. So that'd be one.
So what'd you do after your slide? What'd you do after your slide?
Mirror thing,
Mirror thing?
and then switched it over.
Switched it?
And then negative.
Negative 1?
Yeah.
There's a negative 1.
No, you have to go all the.
What?
Exit out of y equals 0.
This? I disagree.
No, then you have. So,
I challenge.
plus 7. What? Plus 7.
I have a challenge.
And then negative 5.
I challenge you to only translate the X.
No.
And then get to your lock using only a reflection.
I'm not gonna
I guarantee you can. I need to flip this and move this, right?
Oh, yeah.
Since I need to flip it and move it, Naya was telling me to move it first and then flip it. I want to do both at the same time. How far do I need to move while I flip?
1, 2, 3, 4, 5, 6.
I need to go a distance of 6. If I'm going to reflect across something and mirror, how far should my mirror be away to take me a distance of 6? Should be 3, right? So if you go and reflect across that line, it'll do the same. Wait,
It doesn't work. No, it doesn't work.
that distance isn't 6 then, is it? This distance is 5.
6.
Because if I go 6 and I go on the y equals 1,
Oh man.
it's too far, right?
Can you do 1.5?
Ah, if we could do the halves, we could reflect it on what line to get it exactly where I want it. Because that's not 6, that's actually 5, right? We wish it was 6, that'd be better. And I don't want to go 3.
It won't let me do 1.5.
I know. I just wanted to get you guys to the point of frustration. Now, mathematically, we can. We're totally allowed to do any reflection on any line we want. But right now, this is keeping me at whole number values. Right? I can only type in whole number values. So, I have been thwarted.
Wait, so then I was right.
However, I do want to show you something. I do have something to show you.
I was doing
Hold up, check this out, because I'm just trying to show you how we can move with a reflection. Check this. Now, give me your eyes up here real quick. We wanted, because we're working in whole numbers, we wanted this gap to be an even number. Now that I have my gap from where I'm at right now to where I need to go to be 6, I can cut that gap in half and say, okay, where's my halfway point? Okay, at y equals 2. So then, this will work. So still, yeah, Naya, yours would have been just as effective. So Naya wanted me instead to do that, and then that.
I'm still confused on how the reflections work.
See, yeah, thank you, because that's what I was really trying to show. So if you are far away from where you're trying to go, and you're trying to go a large distance with a reflection, you want to figure out how far do you need to reflect and cut that distance in half, or find your point that is halfway between. I need to go a distance of 6 here, from this blue point to that red point. You with me on that? The halfway point where I should put my mirror, right, my line of reflection, needs to be 3 away from each of them. It needs to be in the middle. So that is the y equals 2 location for being 3 away. Because I go 1, 2, 3. And then it will go 1, 2, 3. So here, watch.
I'm confused why it's 2.
Because it's not the amount of space, it's the which line.
This is the line of all points that have a y value of 2.
So it's like a mirror
Oh.
That dotted line is all
Okay,
points
so you want to reflect on the 2 line that is black. Okay, that
because
makes
it's in between. It said you see it happening, like, oh, it pops and goes the equidistant across.
Oh, green.
It's another wall
Why is it green?
because it's a green wall. Green room.
Don't start with that.
Wait, no. Wait, how do we make it start with y?
We can, yeah. Okay, it's gonna take 2 minutes.
Okay, what if we go?
Yeah, I know, right?
What if we go?
Down and then right. Oh, but we can't. Yeah, you gotta
I'll
go.
do the y first.
No.
Andrew.
I know,
I know,
right?
right?
It's so mean.
So if you need to force it, just do one of them.
Well,
Yeah,
but
but
that
that takes-
creates more steps.
Oh, and we can do it. We can do it.
I know.
I
know.
Yeah, because if you have to do one, then the other.
So it's still really
Not in 3 steps.
What are you doing?
Same with me.
Having fun.
That's how half of my things go. Like, one of them are the making steps.
Oh my god.
Yeah, I got mine in 3 steps.
Break
I got mine in 3 steps. What? Wait, can you make it play? Like, all the way through?
Yeah.
Yeah, that's like what I'm getting to.
Hey, can you like make us do this kind of homework for this? Yeah, this would be fun homework. Yeah. Could you assign us like fun sometimes? It's not.
I like big crap.
Maybe by his definition, our homework is fun.
Yeah.
Well, then he's
Oh,
easy to
math homework.
So again, if we're talking about efficiency, this
That
is
is
not
not.
very efficient, right?
That's what has to
It's
wait,
very-
Now play the whole thing.
Yeah, now play the whole thing.
Play it. Scroll up.
Uh-oh.
This is how I feel like when I'm drawing.
You don't draw.
36.
This is like a bad driver trying to get into a parking space.
My God.
18-point turn.
See, you did
This
that
one
in
car
like.
parked in the middle of the road.
So here's another fun thing you can do with Desmos that graphing helps you do. So one of my students in my Math 2 class, I'm going to drag this off the recording window for a minute. I challenged them yesterday to play with our graphing and way too many. This is made with Desmos. out of functions that he plugged in under certain domains. So Chris Koppel in the 8th grade, totally wasn't their homework or anything else. I just put a challenge to them. Because in Desmos, if you go to Desmos' website, they have a creative art section. Desmos is fantastic. So if you scroll down, creative art, all of this stuff has been made using mathematical equations under given certain domains. You can make a SpongeBob. I like the Jeep.
BB-8.
Every single part of this, like the wheel tread, you can look at and see what the graph is.
How do you do that? I want to know how you can control.
And you know how you learn how to do it? You play. You just play. Now, you have to have some basic understanding, like a sine curve does this sort of thing. Sine and cosine and tangent curves go back and forth and back and forth. So once you know that that creates a back and forth and back and forth, you can just modify it.
Here, go back one. So back to the. Did you make the Jeep?
I did not.
Do the BB-8 one.
Yeah, do the
Oh yeah, BB-8.
Somebody made Rick.
Yeah.
So circles are pretty easy to graph once you understand them. So this guy was playing with a lot of circle graphing.
So I can't believe somebody made Rick.
Isn't that sweet?
And it's like a perfect. It's a perfect drawing too.
All right, so that's Desmos, some fun stuff that you can do.
I like animated Desmos.
I need to get to my next puzzle.
That would be cool.
My old t-shirt made a shape thing on there. I don't remember what it was. He spent the entire day working on it. And then I did mine. I made this.
I love it.
I don't remember
Oh,
the
oh,
exact
oh,
date.
oh,
Anyone know how to do this one? You want to come up and do it?
oh. No, why?
Wall 3, it's like puzzle 7.
That's funny because
This
that
is wall
has
3.
really different.
No, but that messes
I
up.
don't know. Saying wall 7 or something.
Okay, I challenge you to do this utilizing a large reflection. So, like, obviously we're going to need to rotate our key. Oh, crap. I was starting in the wrong place. Sorry, I thought we were starting right. So never mind. Big reflection may not work here.
It's so passive. I can touch it. Rotation.
This is actually cool. We're number 9.
We're on number 9.
I'm on 11. Well, actually, I just passed. I'm on 7.
Hey, so notice up here, guys, just a little bit more Desmos info. This is your menu button. So if you wanted to make a puzzle, you have to challenge your friends and create a puzzle. You want to select a puzzle, go here and select the puzzle. Here are the walls. What are you on? Over here, you said one of the stars. Which one?
I'm start. I'm gonna go to start.
No, I think we're on the first star. With the
Look at how hard
I'm going to start 4 after I finish writing this down.
No, go to challenges or something.
yeah, we're on it.
Go to challenges.
Yeah, I want to see what they are.
I'm at a Mr.
Whoa!
Hudson, what if you
You have to
want
reflect it, right? Then reflect it up. Oh, you're blue.
We're blue to start.
You reflect it down, then you reflect it left.
Ooh, so hold up. Bilal thinks that we can do this with just reflections. Sorry, robotics people. This is probably one of the more fun days of class that you guys decided to miss. So, what if I reflect like x equals 1? Crap.
Not X.
Ah, not x. What do I need to do?
A Y.
A y.
Oh, and then you reflect it to the left over X.
X what?
I don't know, but like it's
All right, let's
Zero.
try it.
0.
Ah, not far
Oh,
enough.
2. 2. No, 3. 3.
No,
You're
0.
going the wrong direction.
Yeah, 0.
If you get closer to your original shape, you won't go further. You'll go less distance. So if I do x equals 0, that is the axis.
Yes.
Cacao. 2 reflections. Got let's try challenge 2 before we get out of here.
Yeah.
Yeah.
Starting blue.
Oh, where is it? Wait. I want to write this down. No.
Do you think I can do this through like 3 reflections? I think I can.
I don't like this.
That's not. Oh no, I'm gonna.
4.
No, this one. 1, 2, 3, 4. I know.
What would get me to my end point?
Zero.
Reflect the axis.
Yeah.
Y equals 0, right?
Zero. Yes. You reached the goal. Yeah.
Again, many different ways to do this. Alright, please go ahead and put your Chromebooks away. Plugged in where they belong. And once you pack up, you guys can head out. Have a great night.
That was quite the interesting. Oh my gosh.
I love Desmos.
It's social studies. No, it's social studies. No, it's not. We have no social studies.